So in this video I'm going to talk about making peanut butter and jelly sandwiches, and the big idea is conservation, and the two main laws that we'll look at: conservation of energy and then conservation of mass and matter. These two laws are actually separated, but you often see them combined as one, and I'll explain why in a second. Excuse me. So the big idea here is we're going to talk about peanut butter and jelly sandwiches, and let's say that you have a serving of peanut butter, 2 slices of bread and a serving of jelly, and it equals a mass of 50 grams. So the law of the conservation of mass states that the mass of the starting amount must equal the mass of the ending amount. So in theory, the sandwich that you make, providing you don't make any crumbs and you don't leave any of the ingredients on the knife or spill any, the idea is you should end up with exactly 50 grams of products. So you start with 50 grams, you end up with 50. You start with 1,000, you end up with 1,000. So that's the law, nice and simple. So we can use this information in a variety of ways in chemistry. If we wanted to figure out how much of a gas is produced in a chemical reaction, and let's say that gas was difficult to collect and measure. Remember that gases are obviously very light, so it's difficult to collect enough where you actually can measure the mass in this lab. So if you know the mass of the starting amount, you can actually do the reaction, measure the mass of the ending amount, subtract the two, and you end up with the mass of the gas. And we'll actually do that experiment as to kind of demonstrate this as well. So let's add some fancy chemistry vocabulary. Instead of saying ingredients or starting amount, we actually use the word reactants. So that's what you start with in a chemical reaction. And then products are what you end up with. Alright, so that's straightforward. The arrow, we don't write the word yields above it, but it means yields. So yields, produces, gives you, is what the arrow means. So reactants, this chemical reaction happens and it gives you these products. Conservation of mass states that starting amount must equal the ending amount. So then the conservation of matter law is involved in the first law of mass, because obviously all matter has mass. So the conservation of matter law, we apply that by saying, well, if we start with peanut butter, bread and jelly, we can only end up with a peanut butter and jelly sandwich. We can't end up with an egg salad sandwich or something like that, because we didn't start with it in our chemical reaction. So the things that you start with, the matter, the stuff, has to end up on the other side of the chemical reaction. And so the amounts that you have, so for example, 2 pieces of bread, we started with that, we end up with that. It's changed, it's different, but that 2 pieces of bread still exists, but maybe in a different form over here. So when we talk about chemical reactions, we'll use that law because the chemical reactions that we write out in chemistry a lot represent that. They represent the numbers and types of elements must be the same on this side of the arrow, or the reactants must be the same on the right side of the arrow as products. So you can't start a reaction with sodium and chlorine and end up with carbon and oxygen bonded together. It's not going to happen. You've got to start with the same reactants in the same products, but there'll be a chemical reaction, there'll be some kind of chemical permanent change. Alright, so the idea of energy follows the same pattern as mass, because the law states that, well, actually slightly different, let me correct myself. The conservation of energy law says that you can't create or destroy energy, you can only transform it from one form to another. And a really good example from physics last year is probably potential and kinetic energy. So if a ball's on top of a hill, it's got a certain amount of potential energy, maybe 0 kinetic energies. It starts to roll down the hill, potential energy is changing into kinetic, and then gradually it's losing all the potential energy as it gets to the bottom of the hill. So the idea that energy, the amount of energy is the same, and you can't create or destroy it, you can only transform it from one type to another type. So to talk about that in terms of chemical reactions, we need to get away from peanut butter and jelly sandwiches, and we need to talk about an actual chemical reaction. So let's talk about a good basic one, which is if we take sodium and we react it with chlorine, and I'll actually show you a video of this. Chlorine exists as a pair or a diatomic molecule, so chlorine exists as 2 chlorine atoms bonded together. Sodium just exists as a single atom, but obviously billions of them in one sample. So, conservation of energy, the bonds that exist between the two chlorine atoms, the amount of potential energy that a certain element has, sodium has quite a lot, because what it wants to do is lose that electron that's in its outer energy level and give it to chlorine so the two can form a substance where they both end up as a more stable arrangement of electrons. So sodium has potential energy, so does chlorine. That energy gets transformed in this big violent explosion. So light, heat, lots of energy is given out, and you form sodium chloride. So this has a lot less potential energy than this. So the products, have a lot less potential energy than the reactants. And a lot of that energy that is missing was actually given out as light and heat. There are different chemical reactions that give you different types of energy produced, different types of radiation, for example, but light and heat are very, very common. But that's the conservation of energy. So the amount of energy in this total system, if we kept it in one super airtight container that was dark, didn't let out heat or light, the amount of energy would remain the same in theory. So we didn't create or destroy any, we just transformed it from chemical energy into these different types, and then a smaller amount of potential energy over here. So the big idea of conservation, just to kind of recap it all, it's things staying the same, which is what conservation means. With regards to mass, the mass of the reactants must equal the mass of the products. As far as matter goes, this is another good example. Good example. You've got two different elements here, and they end up as your products. To actually make this follow the conservation law, we actually have to change the numbers in front. So we actually end up with 2 sodiums, 2 chlorines, 2 sodiums, 2 chlorines. This is a whole unit in chemistry that I'm not going to get into right now, but if you can imagine the idea of a peanut butter and jelly sandwich, you start with a certain amount, you end up with a certain amount of the same stuff, but just different combinations. And I think that's going to help you understand matter and mass conservation. And that's it.